Hello everyone, welcome to GrapplTech. This is episode 2 of our complete Golang Bootcamp, where we'll be discussing about the use cases of Go language in the real world scenario. The very first and most important use case is Go is extensively used in web application development. Like if you want to build scalable web applications and if you're trying to build RESTful APIs, so Go would be a better choice because it has frameworks like Gin and Echo, which are very popular choices for web development in Go. And what are this Gin and Echo? I'll give you a small kind of definition to it. So Gin is a web framework which is written in Go. So it simplifies the processes of building web applications and APIs by providing helpful tools and abstractions. Okay, so this is written in Go, which is used in developing these web applications. It will provide you with all the essential tools. Whereas Echo is also another web framework for Go, which is similar to Gin, but with some different design decisions and some advanced features. Okay, so when you're trying to build web applications in like using Go, so if you want to prefer simplicity and if you want to build a straightforward API, Gin would be a great choice. Whereas if you need more flexibility and advanced features which are out of the box, Echo might be the more suitable option. So Go is able to provide Gin and Echo in order to build web applications which are very scalable. Whereas the main use case of Go is it is used in DevOps and automation. Okay, if you're trying to create tools for continuous integration, deployment, and monitoring, so we have like Go would be the better choice. And even the popular tools like Docker and Kubernetes are also written in Go. Here we got some new words, right, like continuous integration. So what do you mean by continuous integration? So this is a practice where developers frequently integrate their code changes into a shared repository, ideally several times a day. So each integration is automatically verified the running tests to detect errors as early as possible. Okay. Whereas deployment is continuous deployment is nothing but this is an extension of continuous integration. So this involves automatically deploying every code change that will pass these automated tests to a production environment. Okay, so this will ensure that the software is always in a deployable state. Whereas monitoring is a practice of continuously observing the performance and the health of an application and its infrastructure. So it involves tracking metrics, logs, and alerts to ensure the system is running smoothly or not. Okay. So simply what we can say is CI will ensure, that is continuous integration will ensure that new code changes are tested and verified frequently, reducing the risk of introducing bugs. Whereas continuous deployment will automate the deployment of code changes to the production. So ensuring that new features and fixes are delivered quickly and consistently. Whereas monitoring keeps an eye on the application and its infrastructure, ensuring it runs smoothly and any issues are detected and resolved promptly. And you can create these kind of tools using Go. And the popular tools are Docker and Kubernetes are written in Go. And the next most important use case is command line tools. So you can build efficient and fast CLI applications using Go's simple syntax and powerful standard library, which makes it ideal for CLI development. And here comes the system programming. So what do you mean by system programming? So in system programming, your entire computer will function as a whole. Okay. Like you'll be directly interacting with your hardware components like memory, all this kind of stuff. So the best example would be our Windows operating system. Okay, we have Mac OS. So the operating systems is nothing but system programming. So in order to create these operating systems, in order to write these kind of low level system programs and utilities, Go's performance and its memory safety features are well suitable for system programming. Okay, so generally C and C++ is highly used when it comes to system programming, but nowadays people are using Go because of its performance, and memory safety features. And here comes the data processing and analytics. Okay, so Go's concurrency features, which we discussed in the introduction video. So Go is a concurrent programming language, so it supports concurrent programming, right? So this feature will help in implementing high performance data pipelines and processing systems. Like, what do you mean by data pipelines? So a data pipeline is a series of steps that move and transform data from one system to another system. Okay, and here we are saying that we are trying to implement high performance data pipelines, right? That means pipelines which can handle large volumes of data quickly and efficiently. Okay, and whereas processing system is nothing but it's a platform which will handle the actual computation and the transformation of data within a pipeline. So high performance processing systems are designed to perform this task quickly and efficiently, often in real time. So we can simply say that data is collected from various sources and ingested into the pipeline. So processing systems will transform and clean the data, often in parallel and in memory to speed things up. Okay, so here we got a word called as parallel, right? That's where this Go's concurrency features will be implemented or used a lot. And next comes cloud and network services. So here we can see that again, the Go's concurrency model, which is very famous, is well suitable for handling network services. And if you want to develop microservices or distributed systems, Go would be the better choice. And what do you mean by microservices? So this is an software development architecture, okay, architecture style, where an application is built as a collection of small independent services which will communicate with each other. Okay, like think of an e-commerce application. So instead of having a single monolithic application, you could have separate microservices for user authentication, product catalog, order processing, and payment handling. Okay, so what do you mean by distributed system? So this is a system where components located on networked computers will communicate and coordinate their actions by passing messages. But the system appears to its users as a single coherent system. Okay, like the internet is a giant distributed system. That would be the better choice and better example to understand. So it consists of many interconnected computers and networks that work together to provide services like web browsing, sending emails, and even streaming as well. So in conclusion, what we can say is microservices will focus on breaking down a huge large application into smaller, manageable, and independently deployable services. Like for instance, we have a banking application. So they might have separate microservices for handling accounts and transactions for loans. In that way, they can have different microservices. Okay, whereas distributed systems will involve spreading these services across multiple computers or servers. For instance, those microservices in the banking application could be running on different servers in different data centers to improve reliability and performance. And if you want to build these kind of microservices and distributed services, Go's concurrency model is a well suitable model. So that is why many people use Go for microservices and distributed systems. So these are the major use cases of Go where we have tons of use cases, but these can be, you can consider these as the top use cases of Go. Okay. I hope you like this video. So please do subscribe to our channel and thanks for watching.